WarsawJS.
Yeah, thanks for the warm welcome. And I mentioned something about the cache stampede, however scary that might sound. And I'd like to show you something about, basically, about the issue. Seriously, I have no idea what's going on today with the resolution, but anyhow, let's just have it. Okay. So here's an example server that uses the Fastify web framework. And basically what it does is it computes some results. The thing is, when you ask it for a result, which is basically a word that's reversed, basically its letters all jumbled up, it's going to do two things in sequence. First, wait to simulate some computation that's fairly, well, expensive. So basically wait the number of seconds that the word has, like the same number that the letters it has. Then you increment the dollars that you spend to simulate the cost of this computation. So you see, it takes so many seconds, so it must be heavy and must cost your company money, right? And then basically generate the result, yeah? So what we're going to do here is demonstrate the two approaches that you can take when it comes to caching, and see how this little trick with promises can help you optimize your app, whatever it is you're doing with these heavy computations. So first of all, obviously we need a cache, which as a map, I'm using the ECMAScript 6 map objects, just not to, because it's less yucky than the opening bracket, closing bracket, yeah? So in this map, we're going to hold our cache. So basically, I'm defining a route that will allow me to request the result for a given word, and basically it's the word in reverse, obviously. But what I'm doing here is, if the cache already has the word, so if I've already done the heavy computation, I'm just gonna fetch it and not incur the processing cost. However, at the beginning, obviously, there's not going to be the result waiting for me, so I need to compute it with the handy wait here, then save it in the cache for the next person to find it, and return the result. So far, so good, yeah? Also, I've prepared a helper endpoint to let me establish what the cost is so far. So let's go to our trusted browser. Can you see this? It says spend $0. Maybe I'll enlarge it just to, it's a really big zero, yeah? So just refresh it just to make sure. Yeah, so right now we're at the starting state. And what I'm going to do now is request some results from the server. So where's my console? Okay, so here's the console, and here's I'm just gonna need one, I think. Okay, so here's a console that uses Carol, you probably know this tool, to request the reverse of the word idempotence. It's not a medical condition before you ask, but it's a hard word. It should take a few seconds to process it, yeah? So let's just launch it and see what happens. Right now, without the ampersand and without the typo 2. Okay, so as you can see, you actually have to wait some seconds because of how we've coded it. And yeah, we're gonna get the result real soon, I promise. Okay, so apparently the reverse of this word is whatever. Well, we've seen that you had to wait a fair bit, yeah, for the result. But now let's see if our caching actually works. Yeah, okay, yeah, it does. But the thing is, we've only spent a single $1, yeah? So that's great. However, what would happen if we were to query the API in a way that's parallel? Like, let's ask it about idempotence 2. It's a harder word, yeah, so 12 seconds, I think. And just spawn a few processes that are going to, do it in parallel. Like, yeah, 6 instances. So by this count, our caching, it should cost us $6, yeah? Okay, yeah, our results are starting to pour in, as you can see, into the console. I think they're done. And the budget is now, it's a bit stretched, yeah. It even went to 8, yeah? Maybe I just miscounted the clicks. Anyhow, yeah, we're losing money. Okay, so now how do we actually optimize this thing? So this is going to be a tricky one for me because on my screen this window doesn't look so nice, but let's have it. Okay, so instead of caching the results, we're going to cache promises for results. So instead of doing this, we're going to do something a little different. So instead of await here and setting this, we're going to do this instead. Like I actually have to be looking at the projector, sorry. Okay, so I'm taking the promise that's, yeah. I'm taking the promise that's being returned from here, saving it in the cache, and now I can return the cache get, and I'm gonna take the word, the key corresponding to the word that I just did. Where to, yeah. Thank you, editor. Okay, so it's a small change, yeah? Well, let's see how it behaves now. Let's see if I got this correct. So if my cache has the word to process in it, I'm gonna return the promise, and else I'm going to immediately populate the cache with the promise that's going to have its next dance registered, and I immediately return the promise, and it's okay because the function is async anyway. So I can return promises from async functions, obviously. So let's see how that works now. I need to restart the server, of course. I can't either determine. Okay, yeah, there it is. So let's see if it's any better now. Oh, but the conclusion. Okay. Okay, we're at 0. Firing up. Just to clear this a bit. Yeah. And now we gotta, like, I think it's 4 of them. So let's wait for results first. There you go. Okay, yeah, the results look fine, just as fine as they did before. And our budget is now, it's now in a much better shape. So using this simple trick, by reusing the same promise and by eagerly saving it in the cache, you are able to actually save virtual dollars, as we've demonstrated. So thanks. This is a simple technique, and I hope it really adds to your toolbox. Thanks, guys.